Done. Every time I have to press it twice. That obfuscates the point of a button. Cool. Okay, so welcome folks to day 3. As has been the same the previous days, on this GitHub page I have for the workshop are all of the materials now for all 3 days, the most importantly the ones we use today. So if you want to, as past, just navigate to that page. I have again the web address up on the board, and then click on the download as zip button. And again, you'll want to have this folder saved to a convenient location. I'm putting it on my desktop, and then I'm going to rename it to something convenient today. I'll call it day 3_materials. We'll do just a little bit more of the navigating to folders using our command lines and terminals. So I want to have that conveniently located in the title. Okay, and then I'm going to go ahead and go, actually I'll just wait a little bit longer before we do roll. And also as before, go ahead and open Spider using your Anaconda Navigator. Today we will talk a little bit more about Jupyter, so we'll come to that in a little bit though. Great, and then from within Spider, we'll open up one of the day 3 student.py file in our folder of day 3 materials that we've downloaded from the internet. Day 3 student py, open. So we should all have a sheet that looks like day 3 out of 3. Welcome to the day, here's a plan for the day. And then the next section we start talking about is lists as soon as we summarize yesterday's final activity. So the plan for today, we're going to recap the last activity from yesterday, and then we'll start talking about lists and while loops and error handling, why it matters, and some examples of error types and how we can handle errors. We'll talk briefly about modules, and then we'll close with showing you Jupyter and kind of some of the pros and cons of using Jupyter versus Spider versus command line. And then we'll have our last activity for the day at the end of that. At the very end of everything, I'm going to try and save about 10 minutes of time so that we can do those same surveys you did at the very beginning of the workshop. We'll do them again at the very end. And these are separate from the evaluations that Eloy just mentioned in the announcement. Right, there are 2 different things. The surveys are regarding your sentiments regarding programming. The surveys, the evaluations that Eloy was talking about are going to be emails where you're evaluating this workshop, my teaching of the workshop, our running of the workshop. So different feedback in different places. On that PC, odd. So have you tried the pressing command spacebar using it to open up the Finder browser, and you type Anaconda, nothing shows up? Same computer. Are you on maybe a different account? No. Same account. That makes no sense. It might be in your applications file. I don't know why it wouldn't show up in Finder. No luck. That's very odd. Yeah, I tried the desktop from behind. Okay. What are we doing? We're recapping. That's the plan. That's the plan for the papers. Perfect. Okay. So the last thing we worked on yesterday was writing that script to compute the reverse complement of a given sequence. We'd start with this, right, by just opening up a new blank script. I might give you one with some prompt, but I'm just going to type this from scratch. The first thing we need in here is this import command and then the sys module, because remember we're going to import, we're going to read in inputs from our command lines or from our terminals. Let's spell terminal. And opened up a chat box. Let's close that. So the idea was we're going to run from our terminals or from our command lines some code that looked like we type Python, we type the name of this file, something like revcomp.py, and then some input sequence ATCGTSE. And then the output should be a printed statement of the reverse ordering of the sequences, the nucleotides with their complements instead. So we need this import sys command so that we can tell Python to read this sequence here as an input for what we're doing. So the goal of the script, this script will print the reverse complement of a sequence. And then the first thing we're going to do is define a temporary sequence variable for the input from the command line or terminal. So I'm just going to call it seq as that temporary variable name, and it's equal to sys.argv square bracket 1. Remember where this is our command for accessing the second object listed, the first input that we want from the command line or from the terminal. Now, the broad approach is we're going to loop through all of the letters in the sequence and then change their value in their order, and then save what we've changed them to. So since we're going to do this looping saving protocol, I want to define an empty object that I can save the new objects to. So we'll define an empty string that will be populated with reverse complement of each nucleotide in seq. I'll call it rc_seq instead of equal to. I press the single quote button twice. So I've defined there an empty string. Now, we're going to write our for loop. I'll write this as for nuke in seq colon return. And now I'm inside the body of the loop. And I decided to use nuke here instead of just the letter I, because I want this loop variable name to be something representative that I'll know what it is by its name. You can use I if you want. That's totally fine. I'm using nuke because they are nucleotides within the sequence. No matter what you do, use something that you'll be able to keep track of and is short. Yeah, exactly. It's oftentimes we think about i's as integers. And if you're doing this approach where it's for nuke in seq, it'll never be an integer. It'll just be each of the letters in seq. So going on, I'm going to use if statements for each case. If nuke in seq, the first instance, if it's an A, then I'm going to change it to a T. And then I'll have more if statements. If it's a T, I'll change it to an A. And then so on and so forth for all four cases. So we'll start with if nuke double equals quotes capital A colon, what do we do? Now I'm going to save in rc seq. So I'm going to type rc_seq equals. And now I can do one of two things. I could type this as rc seq itself. So I say rc seq equals rc seq plus the complement to A, which would be T. Or I could change the ordering here and write T plus RC seek. These are two options. Folks are trying both.
First one doesn't reverse the sequence, though.
Right. So there's an important difference in here that gives you some flexibility to how you want to approach the problem. In this first case, I'm taking RC seek and adding the new letter T to the end of it. So I'll have the same ordering of nucleotides as in the original case. They're just going to be complements. But in the second case, I'm going to take RC seek and I'm going to add T to the beginning of it. So now I'm actually reversing the order. So I can do both my complement switch, A goes to T, and I do the reversal of the order all in the same step. Some folks, you did this first one, and you said, sweet, I've got the complements, now I have to do the reversal, and then you wrote some extra code in one of several ways to do the reversal in a separate step, which is fine. You know, this is, if it's a short sequence, then it maybe doesn't matter computationally. If it's really long, then you might be able to get into an argument about which of these approaches will save you time in the end. For our case, it's certainly not an issue. It's just flexibility in how you code. I'm going to go with this latter case, though, so I can type less and we can move forward. And so this first step is done. If nuke equals A, switch it to T and put it in the front of RC seek. Next case. Else if, so we type elif, nuke double equals, now we just go through all the other possibilities. T, colon, we'll type with copy and paste, RC seek equals A plus RC seek. And everything else will be an else if statement, so I'm going to just highlight and copy both lines from this last example and paste those here. So I have else if nuke equals this time G, then we switch it to a C. And if I have nucleotide equals C, I'm going to switch it to a G. Hi, folks. It's coming for the third day for the tutorial. Okay.
How are you?
I'm good. How are you?
I'm good.
Oh, good. Thank you. Likewise.
Do you have a file by chance, or you have to create
File.
it? Is it like last time? Did you give it a file?
No, I've been using GitHub instead. So go ahead and navigate to this GitHub page. And you can download the directory from there. And then we're using, they're set up as tutorials. We're using Spider to do them. Okay, cool. Welcome to the workshop.
Thank you so much.
Yeah, you're welcome. Okay, and then finally print. So now we can print RC underscore seek for the end step in this script. Press Command or Control S to save the file. I'll call this rev underscore comp. I already have something like that saved. So I'll call this for me day3.py. Save. And then we go to our command line. Careful, look at where, for me, I'm not running from this folder. The directory I'm using is the main user directory, so I have to change directories. So I'll type cd to change directory, and then desktop / day3 underscore materials for the name I gave to that folder. Return, I'm now in that folder. I can press ls, return, and it'll list for me all of the files or other folders within that main folder. And I want to run rev underscore comp day3.py. So I'll type Python, I'll type the name of that file, rev underscore comp day3.py. Now I'll type the input that I want to print out the reverse complement for. And to make sure it works, I'll do something easy. I'll just do A 6 times, G 6 times, and press return. And the reverse complement is printed out, 6 C's and 6 T's. Any questions from folks on what we did there in terms of if you did something differently or had some questions on something that wasn't quite working? Cool. We're going to revisit this problem using a different object as soon as we talk more about lists. So we'll get some more practice with all these ideas in just a moment. So let's jump back now to the day 3 student Python tutorial, and we'll introduce and talk about lists. So we used this a little bit at the end of yesterday, but now we're going to formalize these ideas more now. Lists are another object type in Python in the same way we have strings, integers, floats. We also have lists. You can think of these as one-dimensional vectors, where each element in the vector can be a different type. So you could put inside of a list, in the first element of the list could be a string, a word. The next element could be a number, a float or an integer. The next element could be another of either string or float, or it could be even another list inside. You can nest lists within each other. To define the list, we use square brackets. So for example, I'll define what I call my empty list and set it equal to just 2 square brackets with nothing inside. That's like when we define those empty strings as just quote marks. It's the same idea. Maybe if you wanted to save something from a loop into a list, you would first define an empty list to do that. Clicking on my variable explorer, we can see here's my empty list, size 0. I think no values. Yep, no values. List is the same as a vector in R? Ooh, in R? Are you asking, or in Python?
So a vector in R is called list in Python?
No. We want to, yeah, sorry. I'm not trying to compare lists with vectors, lists in Python with vectors in R. Lists in Python are like lists in R. Yeah. Right, right. Yeah, exactly. This is important for some of you with a little more programming background. In R, you can have vectors, but everything inside the vector is the same type. If it's a vector of characters or a vector of numbers. And in Python, we don't really have vectors. We have arrays. So you might think of an array as a matrix of any kind of dimensionality. And in that case, they're all the same type also. Whereas with lists, in both languages, they can be different types, the things that you put inside of them. So, for example, I'll define a list called my shopping list. And inside it, I'm going to type strings for shopping list items, apples, cheese, and chocolate. There we go. Or instead, I'll call a new list my mixed list. I'll put inside of this the number 123, the string of the words a string with a space, and 2.75, a float. And if I press Control-Shift-Return, that executed just fine. My mixed list is now up in the variable explorer with those entries as we defined. Or we can make a list of lists. So now I'll call this a list of lists. And inside this, the first thing I'll put is my shopping list from before. Next, I'll put in the number 1, now the number 2, or I'll define a new list inside of this list in the place of the 4th object. So here I'll type the numbers, I'll do letters, A, B, C. So now we have a list that contains more lists inside of it, and it executes just fine to show proof of principle. This works fine. Okay, now we can access elements in a list the same way we did with strings by indexing them. And all of the string algebra, the indexing algebra works the same in terms of it starts from 0. You can't use the length of the list as an actual index necessarily. Yeah, and we do it using square brackets to begin indexing. So let's first define a list. I'll call this my nuke list for nucleotides. And it is equal to capital letters A, G, C, T. Now we'll index this list, all caps, my nuke list indexed with a square bracket, and we'll index the first element of the list using the index 0, which should get us the letter A when I hit Control Return, and it does. The output we have nucleotide A. You can also change elements of the list using indexing. So I can type my nuke list, index for the third entry using the number 2, and I can set that equal to the nucleotide capital G. Maybe I want to change that object. Now I'll press Control Shift Return, and if I now add a print statement, print my nuke list, then I now see that my nuke list contains the nucleotides A, G, G, T. We replaced that C for a G using indexing and assignment. Any questions about lists and indexing? I'm going to talk about some list methods in a moment, or next. But. Okay, so like strings, there are a variety of functions that are inherent with lists. And some of these are different from what you've had to work with for strings. So we will quickly examine a few. If you're ever wondering how can I view a list of all of the method names, we can use the dir or directory function and put inside of it a list object. So I'll put inside of this dir parentheses the name my nuke list and press Control Shift Return, and now printed in the console are all of the methods that are inherent with lists. We're going to focus on the second half of this list of methods for lists. List of list methods. So many lists. Append, clear, copy, count, extend, index, insert, pop, remove, reverse, sort. Oh, look, there's a reverse. Isn't that convenient? Unlike strings, right, here's an example already, a different function that's available for working with lists than with strings. So append. The append method can be used to add elements to the end of the list, kind of like the plus operator for strings. So for example, let's append the nucleotide C to the end of my nuke list. So we type first the name of the list, my nuke list, dot to access the method, and then the name of the method append and the object we want to append, C. Press Control Shift Return, and now my nuke list, you see now the size, it has 5 elements inside of it, shown in the variable explorer. If I were to print my nuke list, we now see that it has 5 nucleotides and C's on the end. The index method is nice name. It will return the list index corresponding to the element you ask about, but be warned, it only identifies the first instance of that matching element, not all possible instances. So to demonstrate this, we'll index for the nucleotide G. So we'll type my nuke list.index parentheses capital G, press Control Shift Return, and I'm told the index value 1. Remember, we count from 0, so A is 0, G is 1. It didn't give me a 2 for the second instance of G in the list, just the first instance.
If you wanted to get all of them, is there something for that?
Not an easy function. You would have to make your own function and loop where you kind of loop through all the cases. I don't understand why. R has a nice function for that. It's called a which function, and it will show you all of the indices. And I don't fully understand why R has a nice native function for it and Python does not, and why you would have to just make your own to do it. Because yeah, I have the exact same thought. That's right. It's like, why is that even an option? You don't show me all the entries. Anyways, sort. The sort method allows you to literally sort the elements of a list. It works on both numbers and letters, although when doing these, there's always an implicit assumption about ordering, whether you're counting up or going alphabetically. So we'll try this on my nuke list.sort. We're not adding or removing or searching for individual items, so the parentheses are left empty in this case. And you press Control-Shift-Return. What happened was there was no print and output. It just went ahead and changed my nuke list to have sorted entries. So if I type print my nuke list in the console and hit return, it's now going to give me an alphabetized ordering of the entries in my nuke list. Okay, now remove and pop. The remove method can be used to remove elements from the list as identified by their value, not by their index. For repeated elements, this is only going to remove the first instance of the element. It's not going to remove all of them. So let's try this on nucleotide G. We'll type mynucleus.remove, parentheses, quotes, capital G, Control-Shift-Return. And now again, I'll type print in the console, print my nuke list. And I'm given nucleotides ACGT again, so it only removed the first instance of the nucleotide G, not all of them.
Sorry for the previous one, check. It's giving me the accurately sort or
Which one?
the previous one.
Sort was done alphabetically. Yeah.
Okay, but if it's not if the order was not alphabetical, so it's sorted by the alphabetical order. Yeah, it was sorted. I mean, sort. The function of it is just to sort it alphabetically. Yeah.
Or numerically. So that's why I mentioned that some assumptions have to be made about what the objects are. If you have mixed objects, I think it will still try to sort them. It just might also split them by letters and numbers, order pairing. I'm not sure if you have many options. Yeah, okay, yes.
So sorry, I hope I don't do something incorrectly, but for some reason, like mine removed both the G's.
When you did remove G in quotes,
Yeah.
Did you run it twice by chance?
I'll try running everything again. Yeah, thanks for the recommendation.
Yeah, because if you ran it twice, then it would certainly just remove them both. Finally, pop is another method for removing elements, but now you remove it by the index, not by the element name itself. So we wouldn't type G to remove G. We'd have to type the index for where G sits. So in this case, it'd be 0 is A, 1 is C, 2 is G. So if I want to remove this final G, but using the pop method instead, I'll type 2 for the index, Control return. And now a nice thing is the pop method tells you what it removed as output, just so you have that last confirmation. And as with the strings, the length function still exists, but this isn't a special method just for lists or strings. So we don't have to type the name of the list first. We just type ling for length. And I can type my nuke list, press Control-Shift-Return, and the output printed is 3 for how many entries remain in my nuke list, the 3 nucleotides I have remaining.
If you have a list of lists, can you get the length of each of the lists inside the list?
Let's see, let's try running length on my mixed list. No, my list of lists, there we go, my list of lists. And my first guess, this is going to tell me the length of my list of lists, not the things inside. So press Control-Return, 4, which is the size of my list of lists. But if I want to know how long the things are inside of it, I now need to index this object. So how long is the first list in my list of lists? So I've indexed my list of lists, press Control-Return, and now I get 3. To remind ourselves what that looks like, I'll just type print my list of lists indexed to 0. Now there we go, return. My list of lists is not defined. What? this whole, sorry, capital L's, return. All right, my list of lists. The first entry in my list of lists was the list apples, cheese, chocolate, and I had 3 entries. So yes, you can get the length of the, if your list contains more lists, you can get the lengths of those objects with indexing. Yep. Okay. Questions on lists from folks? All right, then, now that we have a new object, new type with which to work, and new methods, we're going to return to the reverse complement function exercise. Only now, we are going to use list methods instead of string methods. So I'm going to quick open. There's another prompt for starting this. It's called reverse comp version 2_student. And now we have some of the same instructions, only this important step. Note the major difference this time is that we will be saving our reverse complement nucleotides as list elements and using list methods as opposed to string elements and string methods. So you can get some practice doing a similar task with an end result, but using a different approach and type. And just to mention, for the very end, there is a function that we haven't worked with yet, which is going to be what merges your list all into one final string for your printing. I went ahead and just wrote that function use here at the end, in case you're confused about what this is supposed to be. So let's pair off again. I apologize, I ran out of time. I was not able to make personalized little cards of D's and N's. So if you can take it upon yourselves to randomly pair with a neighbor, and one of you choose to be the driver and be doing the typing, and the other one choose to be the navigator and not do any typing for this exercise, that would be outstanding. And we'll go ahead and spend about 10 minutes working on this project.
So in this case, we input the string or
Still a string. Yeah, no, it's, yeah. Imagine the input you're going to have from your command line still looks like this scenario where it's still a string. It's just you're going to solve the problem using list functions instead. And when you define your empty object that you save things to, you'll define it as an empty list instead of an empty string.
then we can join it at the end.
Yep, exactly. And you'll join it at the very end.
That's what I was looking for
Okay.
So then,
I'll do roll while we're here. This is great.
I'm going to go ahead and do roll as now folks are starting to get working. If you can give me a quick present here, raise of the hand, that's excellent. Naomi, great. Theodisi is here. Bue, great, thank you. Tanner, yeah. Nyasha is here. Golnish is here. Neha, yep. George, Xiao's not here. Megan, you're here. Thank you. Right. Kind of Natika, I think. Oh, Natika. Yes. All right, thank you. Feng Fei. Thank you. Alexis. Alexis is not here today. Emily. Grace. No. Johnny. No. Georgia's here. Okay.
oh no.
Just
It can still be from me.
yeah, just let the empty quotes make that screen, right?
So then, if this time it's not recreated, it would be if C could be in the but with the square bracket. Yeah.
The one that defines.
We just started.
When we started, we just started an activity. Shall.
Yes.
Perfect. Yep, of course.
Is that I think it's
Do you want to do this part though? So that we reverse.
It is.
because it's on the string, we just append. So maybe instead what we should do is if C like equals A, then we should just append.
So append it doesn't know it. You have to add it.
But only
It's going forward, right? That reverse like you did.
Yeah, so
So this time, we
That's
have
fine.
to reverse it. So you can't make it say reverse.
choices.
Yeah, because it's the list reverse. Yeah, that's a good idea. Let's do that. So we do C dot. It's just much easier. Oh no, okay, your last statement's fine. And we still need.
Oh, yeah, so I kept it.
Oh, you did, okay.
It was just a second.
This is why,
Perfect.
Like in
Started.
these brackets, right? I just,
Yeah.
but this one.
No, it's not. It's normal. I think it's a function.
So we wouldn't, the thing is that this script wouldn't be run line by line, it'd be run all at once. And from the command lines. For, so from your terminal. Press the command space. And do yeah, exactly. So we would run this file using Python from the terminal. That's not how it's been coded. It's just the way that it's sort of set up. Okay, where do you have this file saved?
is it fine to not have an else? To just have it as
As a folder.
Yeah.
Can you navigate to it easily?
That's great.
Oh yeah, okay. Right. So on, go back to the terminal. Type CD to change directory.
Oh.
Space.
Yeah.
And then type the name of the folder you want to move into next. And then return. And you can keep doing that until you find it. Or you can try and type the entire path. So from here. Yeah.
Oh.
And there you get the path. But you need slashes instead of those dots.
Oh, so I think what they wanted us to do was not to do. Wait. No, never mind, but it just defines it.
This is the same problem that right?
Oh, it's straight.
There shouldn't be an issue. Like whether it's Mac or Windows, it shouldn't be. problem. So this is something different. It might be about how it was installed.
Better read, reach. Yeah, you don't have space in this.
So that is because it's a Mac versus a PC. So yours says like C drive users and overloads. Mine says users out drives. But typing CD in the space bar and then the name of the folder you want to change the directory for should still work here. Try, yeah. Great, it worked. I recognize that. So now, if it's in a folder, is it in a folder on your desktop? So now I need to do this once more. So you have CD space in the folder. File's just sitting there. Yeah, try what you typed up there. What does it say in this message? Okay.
Oh, yeah, you gotta open your,
I don't know.
Which is like, yeah,
You guys have a
you
problem?
can also
Where you
type
with- Okay. This is the last time we're going to use the script like this from the command line. So
Just found the folder, put it here, but what's the next?
hang on a second.
Mine turn. Invalid
If
something.
you really want this to work and to see if it will work, you have to try using one of the desktops in the classroom. Like,
Wait, can we use seek any other time?
but in translation, like I said, this is the last time we'll be trying to run
It's just
scripts with
invalid.
this from the command line.
Is there?
So maybe try start over here in English
Do you have a V after?
for this last one.
Oh, one. You gotta put. Yeah. Oh, yeah, you have two emphases.
Oh.
Okay, well, so I'm going to do this. We'll do it together as a class. In
String indices.
probably 30 seconds. And then
So make these a little
slow because I'm going to, once I have this code, I'll show how to run it again. Sorry. Just let's see how I write it down here. Yeah, that part. So you want to have the written after that. And then I think or I set it to RC. So you want to change it to sure. Not quite. Because here, everything you're still doing here is looking strings. So that's fine. I mean,
Oh, I know.
it might have been a before prompt.
Here,
to make clear what we're doing. So
they are strings.
just hang tight. Like
Okay.
30 seconds.
So-
See how it looks.
Okay, well, wait, make this one. I'm confused.
Yeah, just like run.
Looks like it. Excellent. Perfect. And then YouTube.
So how do I change the working directory? We'll do that together just a moment, because you see if you were the coding part. Okay. Okay. Looks like you did.
I was sort of catch up later. Yeah.
Cool. we'll do this all together. Just want to phrase. Great. Okay. Great. A
little more hiccups on that one than before, but overall, everyone was doing the right thing. So we'll go through this now together as a group and try and address these differences as we go. I have, what did I say it was called? RevComp version 2 _ student is the file we're working from. So, excuse me. So, right, this is like the previous exercise we did just earlier, where the idea is that we're going to run this script file from our command line. So the first thing we have in this script is the command import sys, because we're going to feed input values from the terminal or from the command line into the script. So when we do that, we have to define that temporary sequence variable. So I'll do this again. Seek equals sys.argv square bracket 1. Now, the idea here is going to use list methods. So now when I run through my loop to identify what is the entry in seek, I want to switch it to something else. I'm going to save it in a list instead of saving it in a string. So I'm going to call rc_seek set it equal to an empty list instead of set it equal to an empty string. So I have the list brackets here with nothing inside instead of single quotes. Cool. Now we write our loop again. So now we're going to loop through our input seek variable. So this will be for nuke in seek :return, and then we type the things we do within that loop. Very much similar to what we did before for the string scenario, where I had for nuke and seek, and then all these if and else if statements, and we're doing these string operations. So we started with if nuke equals a, and then we use string operations to merge and add the components together. Here instead we'll do if nuke double equals quote capital A :. Now we'll use one of the inherent methods for lists to do the merging operation and to add a new element onto the list. What is the method that might be useful to use here? Append. Yeah, we have the append function we can use. So I'll type rc_seek.append, and then in parentheses, now I'll just type the complementary nucleotide to A, which is capital T. And then that's it. That's done the appending. And we can't change the order. Append only adds things to the end. We can't prepend like we did with the strings and the plussing. So we'll just have to use another method later. And that's fine. That's just what we have to do. So now we run through all three other scenarios. Else if nuke double equals capital T : rc_seek.append. And now we append capital A. And I'll highlight and copy these two lines because everything else will be an else if argument, and then just swap out the letters as we need. So here I have G, and we'll replace with a C, and if nuke equals C, we'll append with G. Okay. Now our loop is complete. Oh, but don't quite go to the join part yet, because as we mentioned, the ordering is still not going to be right. We haven't done any reversals of the elements. Fortunately, I kind of teleprompted this. We have a reverse method for lists. So now I can just type rc_seek.reverse, parentheses. And that'll do the reversal of all the elements in the list for us. Last part is use.reverse method to reverse order of rc_seek. And then this last part, we just leave this code that was kindly provided to us, where we squish everything and form it into one string with no spaces. If you're curious, note how this method, this .join method, has in front of it an empty string quotation marks. That means that this is actually a method for strings. And what we're doing is we're converting the object inside the parentheses, rcseek, we're going to convert that into a string using this join method. It's a strange method since it takes one type and converts it to another type. But for whatever reason, it's stored with the strings, maybe because the output comes out as a string. Okay, anyways, and then we finally print to the console. So print rc_seek. Now I'm going to save this file. Press Command or Control S, or revconf v2_student.py. So we go back to our command line. As before, I'm still in my day 3 materials folder that I put on my desktop. Remember, I got there typing cd space, and then I typed desktop to navigate myself to my desktop, and then cd day 3_materials to navigate to this folder materials. And if you want to remind yourself what's inside the folder, you can type ls, hit return, and you're shown all of the files that you have inside of that folder. So we want to run revconf version 2 student.py. So I'm going to highlight and copy that file name. Now I'll type Python, paste the file name, and then enter some kind of arbitrary test sequence. Again, I'll just do 5 A's and 5 G's and hit return. And I'm presented with 5 C's and 5 T's. And so we have now 2 functions for doing the exact same thing. They just use slightly different methods. If you dig around enough on the internet, you can find some fun arguments people make that will get into the nitty-gritty about how Python works and try and convince you that one of these methods is faster than the other if you're doing this operation with 1 million or 10 million nucleotides. I don't actually know that off the top of my head, but those are fun articles to read sometimes, if that's your thing. Okay, any questions on this activity, lists in general? We're going to move on and kind of dance around between a few new objects and subjects for a little bit before we come back to some more practice coding. Sure. What happens if we don't use join? I'll put a comment in front of join, press Command S to save this. This will be interesting. Let's see what happens. Go back to my command line, press up, hit return. Oh, look at that. It printed a list of strings. So it's done everything here except for the final joining of all of the elements into one string. So instead here, it's just that, okay, the loop started with making the empty list, and then it went through A was an A, so it set it to T. And then A went to T, A went to T, A went to T, and then we had the G's went to C's, and then we reversed the order, so that's why it's all C's and T's. We just didn't ever do the joining of all the elements into one string. So our output now is a list. Excuse me. Any other questions?
When you read the argument variable, can you read it directly from string to list?
Asking about this part?
Yeah.
So this, right, there are already interpreted as strings.
Right.
You want to
read those strings as individual element within the list.
You can't index within a string. That's a Python rule. You can't index the second element of the string.
The string is just pretty much a list of characters.
yes. Is that right? Yeah. The string entry itself is.
You can't index within the string. You can index on an entire string if it's part of the list, but you can't pick out elements within the string. Fill into that trap.
If I type test string and then do ABCD, close quotes, and then I type test string and I index with the number 0, I have to end my brackets. Sorry. Is this different from what you mean?
No, I'm just wondering whether you can read the string immediately into a list.
Okay.
Yeah, it's okay. I mean, like, there's better way to do it.
Yeah, I'm going to say we might be able to coerce it
Right.
if we type list.
I'm just curious whether there's a way, like, when you read the string, you can automatically ask Python to interpret it.
Yes. Yes, there is. Use the list function
Oh,
and then put the string inside of it.
I see.
So it's coercion.
Yeah.
Kind of like when we convert floats into integers, for example.
Exactly.
So here we would put the sys.argv entry inside of the list function, and then now it's a list to begin with.
Right.
Yeah.
Thanks.
And we could still loop through it
Yeah.
here. Actually, I don't think that'll change anything here. If I save and run, yeah, we still have the same output in the end. Cool. Other questions from folks? These are all great. Okay, then let's talk about one last type of object, dictionaries. So dictionaries are yet another object type in Python. They are specific to Python. As we had a good discussion, lists are quite common in other languages, but dictionaries are unique for Python. They're similar to lists, but instead of having indices and values, they have what are called keys and values. So you can still index your entries in the dictionary, but you can also, if you want, have a name or a key associated with different items inside of the list. Keys can be strings or numbers, and they can serve as unique identifiers for their paired values. Like lists, values can be anything. They can be mixtures, strings, lists, or even other dictionaries. We'll do just a few kind of coarse examples to show the idea here. So I'm going to call this dictionary a dictionary of experiments. And to define dictionaries, we use the curly brackets on the keyboard. So not the square brackets, not quote marks, we're using curly brackets. And so my first key value pair is going to be called control. So I'm using a string and the letters control. And then I pair the key with its value using a colon. So we're not indexing here and using colons. This is a very different use. We're using a colon to associate a key with its value. So the value here is going to be the value of 1000. And then comma to separate this key value pair from the next key value pair. Next key value pair, I'll label the key as exp1 for experiment 1, a colon, and then the value of 500. And then the third and final key value pair will be exp2, colon, 600. And I'll press Control Shift Return. And now I've defined an experiments dictionary. You'll see the type is labeled as DICT as an abbreviation for dictionary. And the size it lists as 3 pairs. It doesn't list 6 because I have 6 things in there. It lists 3 as in 3 pairs. Each of those pairs has a key and a value. So I can call the name of the dictionary to view all the elements. I can just type experiments, press Control Return, or I could type it inside of a print function and press Control Return. And it shows me all of the key value pairs. Excuse me. I can index the dictionary of experiments now by key names. So for example, I'll type in quotes exp1 in square brackets, press Control Return, and now what's returned are the value that I associated with that key, the value of 500.
Is there a reason we don't use the curly brackets for indexing dictionaries?
I don't know. I think it's, if I just had to guess, it's to make all indexing operations use the same characters, no matter what type of object you're using. If you're indexing arrays, like 2-dimensional matrices, for example, you still index starting with square brackets. You just change, you have like an X and a Y or a row and a column, for example, but it's still square brackets. Maybe I want to change the value that's associated with the pair. I can type experiments, square brackets, and I'll type exp2 because I'm going to change the value associated with the key exp2. And now I just use assignment to change that value to 300 and press Control Return. And then if I type experiments one last time, I can see all of the key value pairs, and I can see here I did in fact change the value associated with that third key value pair. We're not going to use dictionaries much more than that at all. Since they're kind of a special use subject, I just want to like bring this thing to your attention so that when you see this in other codes you may find online or try using it, you're at least a little familiar. For time, I want to make sure we have enough time at the end of today to actually work on this last activity. So I'm going to skip this next part where I was going to revisit this reverse complement exercise and do it a third time using dictionaries as opposed to strings or lists. It's kind of a slick use of dictionaries. You basically just have one entry in your loop instead of 4 because you use a dictionary to form key value pairs between A and T, T and A, C and G, G and C. And then you just index the dictionary, and that does all of the switching for you. It's neat, it's cool. The code is right here, so on the materials I post online, you can find them. But I want to save us the time moving forward. So are there questions, though, on dictionaries?
We can use the function for the list for dictionary.
Length?
Yeah.
Yes.
For the
List.
the function that we use for the list, like append.
Oh, what are some methods, maybe? Directory, experiments, control return. We have here now a list of dictionary methods, and focusing on the second half, clear copy from keys, get items keys, pop item. So nothing like quite like append. No.
Because we were talking about the loops, I was just thinking that the function that is instead of append, that loops of.
Oh yeah, it's okay, yeah, to give it's not using dictionaries in that way. The dictionary is used to do the switching and the ordering. It's still done, it solves it like a string problem. So it makes an empty string and then populates the empty string using the plus sign. I see, that was a fair question. Oh, there were fair questions, I get that. Never mind. Other questions? Okay. Going on, modules. So we spoke a little bit about these yesterday. We're gonna actually delve into this idea just a bit more today and get some practice. Modules. Suppose you have a custom module that you've made and you want to load it and use it. Running a custom module can be tricky if this file is not located in a commonly searched directory. Right, so what do I mean here? Why do you have a custom module in the first place? Well, if you downloaded the folder for the course, you do. So I'm going to open up the day 3 materials folder, and in there is something called stats_module.py. The idea here is maybe we're doing a special analysis and we're going to follow it off of a friend of ours who did the special analysis, and they wrote a module with special analysis statistic functions to do their special analysis. And they said, sure, here's my code. I wrote it as a module, and they send you the file. And you say, great, thanks, I can't wait to use it. I'll give you a tip. No. So here's a file. It's full of a bunch of functions defined how we did in that first day where we say def for defining the function. There's a function name. It takes a parameter, it does something with it, and then returns or prints some final thing in the end. These aren't very special functions at all. One is the cumulative sum, another is an average, variance, standard deviation, but they're just made as examples. So we have this file that's just a whole bunch of functions in it, which is essentially all any module is. So how do we get our Python interactive environment to find and load that module, since we got it from our email, for example? I'm not done with that page. So we could just try typing. Do this here. From stats module import star, import everything and see what happens. So press Control Return, and oh, I have an error. In my console, it says module not found error. No module named stats module is found on your computer, or at least wherever Python tried to look. It turns out that when you downloaded Python and all the sort of the bundle of modules that come with it, they were all stored in one location where Python knows to always look, which is why I couldn't find the one that you have in your email or on your desktop now. So what we can do is import, again, the sys command. I'm going to comment away this, oops. I'm going to comment away this from stats module import command and instead just have this import sys. And then I'm going to execute the command sys.path. Press Control Return. And now let's look at our output here. So we imported the sys module, and now we ran the command sys.path. And what we're looking at are all of the common paths or folders that Python looks into to find modules. The site packages and site packages like Python, and so these are the main locations where all of your modules that you downloaded with Python are already stored. So we're going to add the location of our stats module to this area instead of adding that stats module file into one of these paths. So I want to add my desktop and day 3 materials folder to the list of commonly searched paths. So I'm going to type sys.path.append. Right, we're using the append method because the sys.path object is in fact a list. Notice the square bracket at the ending and at the beginning, and every item separated with a comma. This is a list of paths, so we can use the append method to just add a path to it. And that path will be, in quotes, for me, on a Mac, I have to type users. All Macs, it should be the same. If you're on a PC, I think you're gonna have to start with like C: for your main C drive. And then remember, Macs, we all do forward slash or upper right to bottom left slashes. If you're on a PC, you're gonna have to use the other slash, the names of which I always forget. And then my user account is AlexWork, and then I'm going to the desktop, and then the day 3 _ materials folder, where that stats module file is located. So I'll press Control Shift Return. And if I want to check to see that this worked, I can type sys.path in the command line, or sorry, in the console once again, hit return, and I'll see at the very end is now this new path that I've added to where Python searches for modules. So we'll try this from stats _ module import star command once again. Press Command Return, Control Return, and now it executed without any errors. So now we have all of those functions from our module available for use as we'd like to use them if we need. I could type the name of one of them. I think it was sums, or maybe variance nums. There we go, with a capital N. Variance nums. Good. Now it's recognized with tab completion. It says add some numbers in here. We'll calculate the variance nums, or the variance of those numbers.
So was stats module a user-defined file?
Mm-hmm.
So when you tab complete, and even myself, and since it wasn't on the path, how did it know it existed?
Hang on. When you tab completed when?
So when you first, even at the very beginning, before we added that folder to the path, and you did import or from stats module import, when you tab completed, it was there already. Same as for me.
Oh, I didn't know that. I didn't see that. I thought I was just typing.
Oh,
I
for
did-
me, when I was
You did tab complete.
and it was under there, it was there. I don't know if it was just guessing, but if
Cool.
it wasn't a part of the path, I was confused.
It is odd. Did you try running it and you got that error?
Yeah, I got the error. Same, everything happened, but it's just when I tab completed, it was already there.
Very cool. I don't know why tab complete would be able to find it, but then when Python isn't finding it correctly, might be tab complete is searching recently clicked on things, and since it was in the folder you downloaded from your email recently, that was kind of fresh in the cache for the tab complete function. Oh, I'm just kind of throwing together some ideas there. There were two hands up about, yeah, go ahead.
Or like between like users and one too. Yeah, I think it used to. I have the same problem. I used to. Yeah.
Oh yeah, cool. Thank you, Windows peeps. And there was another question. Maybe it's answered.
So
Go for it.
change the path of the sys that you want to import the original folders module. You have to change it back to the original.
I'm not sure. Can you say a little more?
Like now you already changed the directory of the sys, right? Or the path of the sys.
Oh no, I added it to the list of places to check.
Oh, you just added it.
Yeah.
Okay.
Yeah, I didn't like actually change or ruin anything. Or yeah, it's just been added now to this list.
Yeah, because of that.
Yeah, exactly. And actually, I think this is only temporary. I think as soon as I turn off Spider and open it up again, this location is no longer included, and you have to again point to that path. Which is why now when you download new packages or modules, they're automatically sent to these locations, so you don't have to keep doing this. This was more just a special use scenario.
That's one of the things Conda does for you, the right path and your default.
Yep. Yeah, Conda as Anaconda, exactly, as a package manager. Yeah, yes.
Is there a way to permanently set like a new directory like that?
Probably.
Okay.
And if I were to find it, I would literally just type permanently set new sys.path folder or directory. Since it reverts, I'm guessing it's something done for safety, so that you don't accidentally have things being saved in different locations. But yeah, it's I'm sure you can set it to be changed permanently. Other questions? Cool. Let's see. Okay, this is excellent. We're going to now talk about while loops, and then we'll take a break because we're going to just use while loops for the rest of. There's some more examples afterwards. So we'll introduce this idea. It'll be quick since we're all very familiar with our for loops, and this is just a slight variation on the theme. So while loops. In certain scenarios where iteration is required, you may want a loop to run during a duration of time while some particular condition is held. Right, our for loops have all been run this loop for a predetermined amount of time. I want to run a loop from the start to the finish of this list, or from the beginning to the end of this file. But maybe you actually want the loop to run as long as it's not after 5 p.m. in the day. Because maybe you're running an experiment that's collecting data and it ends at some time of day or ends at some temperature that might get reached in a chamber. While loops allow you to execute loops as long as a given condition or compound conditions are met, as long as they're true. The caveat with these though, and why you don't often do these before you do for loops, is because if there's some error in how you've set for that condition to be met, and it's never falsified, then the loop continues forever. And so it's very often the case that when we're first learning about how to write while loops, or even after you've written many and you just experimenting with your code, you might write a while loop that will continue forever until you either interrupt it or you turn off your computer. I think we're going to experiment with that. We should be here. Okay, so the general form of a while loop, here in comments, you type the word while as a recognized object, and then you write down whatever the logical condition is that you want to make sure is true. And then colon, and then return, and then everything that will be executed during that loop is contained in the remainder of within that loop. Let's do some examples. I'm going to first set a condition, and I'll just write the phrase example underscore condition equals true. So really I'm assigning the value of true to a variable name example condition. But that's the idea here. Excuse me. Now, we're going to write a while loop that's contingent on example condition having the value of true. So I'll type while example underscore condition colon return. And this variable example condition has just been defined to be true, so this will continue running. And then inside, I'm going to type example underscore condition equals false. So the first time we run this loop, the first thing we're going to do is change the value of example condition to make it false. And the next thing we'll do is print the command or print the statement. This will only print once. Right, so we have this example condition that's been made true to begin with. We enter the while loop. The first thing we do in this loop, it's a little contrived, but we're going to do this just to demonstrate a couple of points. But the first thing we do is redefine example condition to be false, and then we print a statement, and then because it's a loop, when we reach the end of the code inside the loop, we go back to the beginning and check, is example condition true or false? Well, since it was set to false previously, then the loop's going to stop. And hence why we should only have this print statement go once. So let's hit Command Control Return to run that code. And now we see, okay, here's the code I ran, and then here's the output from the print statement. This will only print once, and it stopped. Nothing more happened. However, if I go back above, I'm going to rerun this code that sets example condition to be true. I'm going to put a comment in front of the line inside of the while loop that sets condition to false, and then I'll run this code. So now this example condition will always be true. I hit Control Return, and now look what's happening on my console. We just keep printing the phrase, this will only print once. And we've made an infinite loop that's just going to keep running and running and running and running and running until we do something to interrupt it. We can interrupt these by, fortunately, there's a big red, not that, well, there's a red button. It's not very big, but right here, that means stop. And that'll kill, like I said, a keyboard interrupt, and it ended that loop from running. Okay, that was contrived. Let's do some slightly more useful example. Instead of using the condition I had before, I'm just going to define count as a variable equal to 0. And now my while condition will be while count is less than the value 40, colon, we're going to now do something. I'm going to print the value of count. And then I'm going to reassign count to be equal to count plus 1. So now, each iteration of this loop, it'll print the value of count, and then it'll increase the value of count by 1, go back to the beginning, check, is count bigger, equal, or smaller than 40? As long as it's smaller than 40, print count, increase it by 1, go back to the beginning. So press Control Return here, and now we have, we've printed integer values from 0 to 39, and then we stopped. Because the next case, count was made 40, and 40 is not less than 40, so the while loop ended. Okay. Any questions on while loops?
While loop always executes once.
As long as it starts true, your condition, yeah.
I set it, I just set for grids, I set the initial condition false, and it's still printed once.
Like in this scenario, you mean?
Yeah, so go to example condition, set it false, then run that, and then run the next. Still printed.
Well, sort of. So we be careful. This is the code that we executed, but there's been no print command here. Yeah, yeah, exactly. Right. Yeah, it should definitely not run once, even still, because we have to kind of control that case. Yeah, yeah. Yes.
So that, when you just say while example condition colon, is it assuming it's a default that's saying while example condition equals true?
Yeah. Okay. Yeah, exactly. So we could write here exactly equals true, and now it's doing a comparison. Is this thing that you define this variable, which is defined to be true, does true equal true? And so as long as that is held, then yes, it's gonna keep doing it. Whatever thing you have written here, it needs to, in the end, result in one single value of true or false, and that's what's parsed for the while loop to decide to move on or not. Other questions? Yes. Here, then it would only run once if that condition were true. And then, yeah, so as long as it's true, while keeps running. And that's a good segue for a last comment I want to make. Loops and logicals, none of these are exclusionary. You can have while loops inside of for loops or for loops inside of while loops with if-else statements all over the place. It all kind of depends on the logical structure you need for the problem you have to work on. They're not, there's no problems with having these things inside of each other, or like a for loop inside of a for loop. That could be very common. Maybe you have an array of data and you have to loop both along the columns, and as well as along the rows, as one example. Okay. It's break time. I just want to make sure I don't have any other thing I want to mention. Yeah, that's good. Okay, great. Let's take a break. Let's come back, make it a 10-minute break. So we'll come back and start at 3:05 in 10 minutes from now. Charger. I need a charger. How's it going? Sure. Okay. All the so I'm going to get this now. Good. Why do you feel this was the issue? That's why. Okay.
I'll be doing 15 minutes.
Okay. That's fine. Yeah, thanks. I think we have almost one. So let's go ahead and start back up. So the second half for today, we're going to talk about two final ideas and then put all these ideas together into the last exercise. This first idea is regarding error handling. So for those of you maybe just getting into programming, for those of you who've been doing this some and you can attest, a simple fact is that when you're writing your code, you're going to make errors. It's totally normal. There's nothing wrong with it. It doesn't mean anything. I write errors all the time, every day when I'm writing code. And knowing how to interpret and handle the errors is a really important part of programming. And languages, despite how it looks, they may, the truth is they're usually try to make error messages that are informative and give you some hints as to where the errors are that are affecting your code. So within Python, broadly speaking, there are about two types of errors that you will run into. There are errors that occur in the interpretation of the code that you've written, such as syntax errors or indentation errors. And then there are errors that occur during the execution of the code, which are called exceptions. Examples of those are value errors or name errors or divide by zero errors. We're going to go through a few examples that trigger these different error types so we can see an example of what leads to these errors, what the error message looks like. And then we're going to talk about what's called error handling, which is writing special code that will handle these errors when you expect certain types to show up, which is pretty common if you're assuming you have standardized data, for example. So, syntax errors. I'm just going to be typing some code that will generate the needed error. So first I'm going to write statement equals true, because we're going to write a while loop that'll generate a syntax error. So first I have statement equals true, and then while statement equals true. Oh, man, I tried to catch this. I'm not going to have the colon after the statement. So I have while statement and I hit return. Spider is very kind and it knows that it will generate an error. As soon as I hit return, Spider is in putting a colon in place to prevent an error from happening. The point here is to have that error occur, so I'm going to delete that colon. So I simply have while statement, no colon, and then a print command. This will print once, and then we'll set statement to false. So it only actually prints once in that loop. And then I press Control Return, make the console window a bit larger. And so it tried to run the while loop, and it got to the end of the code I executed and says, oh, careful in this file you're running in line 3. So in this cell, in this block, in the third line of code that they're executing in this block, it encountered a syntax error as the type, and then sometimes they come with these little messages. To be a little bit more specific, it says invalid syntax, and there's a caret here to try and point out where Spider is guessing this error was occurring. And usually it's fairly accurate. It's showing you where the error occurred, either immediately because I'm missing a colon, or because maybe it's pointing at a variable name statement and there's something wrong with that variable name. We'll come to that later though. So here it says, great, syntax error. I needed to include a colon. So when I put that colon in place and I hit Control Return, the code executes without a problem. I'll delete that colon though, so you still have an example of code that's going to generate the error. Another example is an indentation error. So I'm going to copy and paste the while loop block from above. And I have statement equals true, while statement, I'll put the colon back in place so we don't have the syntax error this time, but I'm going to remove the tabs in front of print and in front of statement. So now I just have everything is left adjusted within this cell. Now when I press Control Return, I get a new error message. Everything tried to run, and it's showing me the line of code that first generated the error. And then it says I have an indentation error as a type. And then the message is it expected an indented block because it has this while statement says we're going to make a loop, and Python expects to have indented code as in the next line after you set up the loop. So I can come over and say, great, thank you, Python, that's helpful. I'll put a tab in front of print and try running this again, press Control Return, and it's running. Uh-oh, I have an infinite loop. Yep, exactly, statement false. It's not really an indentation error, right? I mean, it's doing what I don't want it to do, but it's also doing exactly what I've told it to do. Caution, sometimes you'll have errors that aren't flagged, but they lead to the code that you don't want it to do. That case is tough. That's a type 3 error, I guess. Okay, so we indent both statements. This loop will run as it should, no more errors in that instance. Okay, let's examine now some execution errors. Starting with name errors. So I'm going to type the variable name some text and set it equal to itself, again, some text plus 2. Suppose we're doing some reassignment of a variable name, but we never defined that variable in the first place. What happens when I try and run this, press Control Return, I get a name error, which simply says that the variable name some text has not been defined. Another type is called a value error. When I type, I use the integer coercion function, the function that's going to coerce floats into integers. Suppose I feed that integer function a string, the 3 letters AAA, and I'm trying to run this code. I get something called a value error. In a more specific case here, it says invalid literal for int function with base 10. In other words, whatever I put into the integer function is not something that can be converted from a float into an integer because it's just a bunch of letters. And so this is a value error example. Divide by 0 error happens often enough. It gets its own name. So I'll just type 1 divided by 0, press Control Return. And Python says, sorry, you've encountered a 0 division error. And the message there is, you divided by 0. I like that gets its own name. Okay, so there's a few examples of error handling. You can find online lists of, like, exhaustive lists of all these error names. I don't keep them all in mind when I'm doing code. When I'm trying to error handle, I just basically make, I do what we're about to do for all the different types that just pop up as they pop up. Well, let's do this next part and it'll be helpful. So, error handling. If we expect to receive some errors as we're looping through a set of data, then we can try and handle those anticipated errors using what are called try and except functions. So the function tries to do something, it tries to execute some code, and then if it gets some errors of a certain type, then it runs the exception codes for what to do when those different error types pop up. And a very common list or example of this is maybe you collected you have what you thought was standardized data because different people were entering data, and for whatever reason, they entered things differently. So maybe they have different ways they entered NA values in the data, or maybe somehow the date was formatted differently. And so, you know, as you go through one person's entries, everything's the same, and all of a sudden it changes, and in that change, maybe there's some kind of error that occurred. Let's make a short version of that scenario by defining what I'll just call num list. And in here, I'm going to type some numbers as a list: 1, 2, 3, 4, 5, letters A, B, C, 6, 7, 0, 9, 10. So I have this num list. Most important part is a bunch of numbers, and in these numbers I have also the string ABC and, importantly, the number 0, because we're going to trigger 2 different types of errors when we work on this. Press Control Return, so num list exists, and now we go to the next cell. So let's suppose we try to loop through this list, and for every entry in this list, we're going to divide the number 10 by the value for each entry in the list. So we're going to loop through the list, and in every instance of the loop, we'll divide the number 10 by whatever entry in the loop we are in for the list. We'll type for I in num list, colon, return, print 10 divided by I. So first it'll be 10 divided by 1, and 10 divided by 2, 10 divided by 3, 4, 5, and then when we get to 10 divided by A, B, C, we should get an error. Any other anticipated errors? Knowing, yeah, 0. We're okay. I also have a 0 in here. We're going to do 10 divided by 0, so we can expect a 0 division error as well. Let's try running this. Press Control Return. All we get to is in line 2, so it's just saying, okay, inside of this loop when it ran, we tried to do print 10 over I. We have a type error, unsupported operand types for int and string. Yeah, good. Integer and string. That's us dividing the string ABC into the integer 10 on the top. If I made this 10.0 and hit return, then now I have essentially the same error message, only now it's float and string, because 10.0 is a float, not an integer. And so it's kind of helping you identify the different types and where this error occurs. So the important thing is the error type. The message is one thing, but the error type is what we use to handle the error. So take note that it is a type error when divided by ABC. So now let's use the try and accept functions to handle this error. So we have our for loop again, for I in num list, colon, return. So now what we're trying to do is print 10 divided by I. So first I type try, colon, return, and now I write the code that I'm trying to execute. Print 10 divided by I. Return, delete or backspace so we can get back adjusted with the try, because now we're going outside of the execute code for the try, and now we're going to set up the exception code. So I'm going to type except space and then the name of the error type, which in this case is a type error, and then colon. So now it's looking for any instance of a type error that may occur. It's not going to be specific to the ABC, just any instance of when a type error will occur, it's going to do something. So what we'll do here is we'll execute a print command. And this will be, what do I have here? In quotes, I have ampersand S space is not a number, quote, ampersand I. So if you remember from end of a couple days ago, we had that, or yesterday, I think we had that fancy print command to use the ampersand symbol so that we could change the print statement as we went through a loop, or as we went through a function and have some variable input, I, because I can change depending on where we are in this loop. I want to be able to say, oh, okay, what is I that's generating this error to occur So I have this print statement that lets us say, oh, it's a string that's going to come in. And so we're going to insert a string into the statement that'll tell us it's not a number. Okay. So let's try running this block of code. Press Control Return. Oh, what happened? Always scroll up on your console to see what was executed before your other errors occurred. And we see, oh, okay, this is great. Here's the code that we tried to run. Here's our output, 10 from 10 divided by 1, 5 from 10 divided by 2, 3 1/3 from 10 divided by 3, 2.5 from 10 divided by 4, 2 from 10 divided by 5. Oh, and then ABC is not a number, is the printed output from our exception when I took on the value of ABC and it tried to divide 10 by ABC. So that part worked. Then I went back on to the rest of the list and did 10 divided by 8, 6, thanks. Yeah. 10 divided by 6. This must be 10 divided by 7. And then, oh, something new happened. Traceback, most recent call last. Tells us where in the file an error occurred. New error, 0 division error. That's where we tried to divide 10 by 0. So we hit a new second error inside of this loop. Okay, no big deal. If we expect it to happen more, and we don't want this loop to be interrupted, then I'll just add another exception to the code. So I copied and pasted this loop from before. I'm going to hit return after this print statement, delete. I'm just going to type except once more, and we'll add another exception. Except space 0 division error is the name of the error type, colon return, and then now we write code that we want to have executed when this error occurs. So I'll just type in quotes, cannot divide by 0. Control return, run the whole thing, everything works, and now we have our 2 error messages from our error handling and everything else executed as needed. You don't have to have an error handling message go out if you don't want to. It's a good thing to have, just so that you can be able to go back later and see that errors occurred and you have some kind of message to indicate it. But there's no rule that says it has to happen for anything to work. Okay. Any questions on error handling? Yeah.
Can we put 2 errors on the same set line? Type error or
Mm,
can only put 1? I'm just wondering.
I don't know.
Oh, it's okay. Ignore it. No, I fired.
Oh, and it didn't. Yeah. Yeah. I've always thought of it as something that you do just one case or the other. Because so maybe one way to help answer, you'll never have something be categorized as 2 types of errors. It's always going to be identified as one type of error only. Whether what's actually causing that is what you think it is, and maybe who knows. But yeah, so that might be why it's not obviously working when you try an or in there. Other questions? In the activity we're going to have time for later today, you'll get to practice with this. I have a fake set of data provided you with where you're going to loop through the whole thing, and in there are just some randomly thrown in non-number values that are going to throw errors on you. So you'll get to practice with this. Let's see. Here's just a quick idea to keep in mind. Sometimes you'll get an error message and you have no idea what to do in terms of handling or how to resolve the problem. A very common approach, I highly endorse this, is search the internet. Because here, this is what I found in my own personal experience. The chances that someone ran into a similar, if not exact, same error while trying to do something similar to you or exactly the same as you are very high. I generally do a Google search of the exact error output from Python and look at results from websites like Stack Overflow. That's like a blogging site where people will post questions of what errors they found. I like to think that I do a fair amount of coding. I've never had to actually ask, I make my own blog post. In the 10, 15 years I've coded, I've been able to find other people who have already asked that same problem, and then like a nice vibrant discussion resolving the problem. When I mean highlight it, it will be something like, yeah, I'll just highlight this whole thing, copy paste it, or maybe highlight like other sections that might have found the problem. Google, amazing. Okay, file input and output. Our last broad theme. So, a very common practice you'll be doing in programming is the need to open and examine the contents of a file and or write your own output to a new file or append output to an existing file. We're going to go over a few quick examples of doing this for text files. There are so many different file formats and different functions written specifically for the different file types. The advanced Python course and the image processing Python course most definitely examine doing this for different file types. We're just going to focus on text files given the nature of the kind of work we've been doing. But the general ideas are still the same. We are opening and closing files. So how do we start? We're going to start with the act of writing to a new file. So suppose we are doing some analysis within Python, and we're going to write output to a file so it's saved and you can see it later. To do this, we use the open function, which opens a file for us we can write content to. So I'll type file equals open, and then in parentheses, I have to type the name of the file we're going to open, and it doesn't have to be an existing file. I'm going to type file name dot txt, close quotes, and then comma, and I'm going to type in quotes W, which is a parameter for the open function, which determines what I'm doing, if I'm writing a new file or if I'm appending content to an existing file, or possibly even reading from a file that already exists. So here we go. The open function with the W parameter tells Python to make a new .txt file with the name filename.txt. Inside the function, not the file name. Yeah, so you'll see here's a file name inside the function open, and then I have a comma and a space, and then I have W. Right, the separate function. Yep. Same idea, different, yeah, different interfacing, different approach for the things. One thing to note, you might be wondering, where will this file be written? It's not out yet, in a directory, but which directory? Nice thing with Spider tells you the directory that you're actively working out of. So up here in the upper right, this tells me, oh, it's going to send this to wherever user's Alex work is. I would like it to go somewhere a little more useful. So I'm going to go here and navigate to a different directory, either through recently used ones, or you can click on the folder icon and then select the directory itself. I'm going to use that day 3 materials folder on the desktop. So with desktop, day 3 materials, and I want to save this file I'm going to write to this folder. So I'll type open, and now I'll have this whole path for where this file I'm writing is going to go. Sorry, the little folder icon here I clicked on. And then it gave me a navigation tab to find a directory. Okay, I haven't executed any code yet, mind you. I'm just, all I've done is type this line, and then we set the directory for where to write the file. Alternatively, you can type the directory as part of the path and part of the file name. So we could have, if we wanted to, we could have typed users, Alex work, desktop, day 3 materials / now the name of the file. That also totally works. Okay. So we're going to loop through our num list from our error handling section and print the results of our division to this text file. So I'm going to highlight, copy, and paste that line, the code from before, this for loop with the try, except, accept. Copy. Scroll back down. Paste below. Only now I need to use a different function. Instead of the print command, which prints output to the console, I want to save these outputs in the file. So I have to now use the file.write function to do that. And then I'm writing things to a text file. So the last thing I'm going to do is use the string function to coerce the output into a string. So I have 10 divided by I inside of the string function. And then the weird part, we're sort of building this text file from scratch. So we have to tell Python and more importantly, the .txt file structure when line breaks occur. And for text files, line breaks occur when you encounter /n characters as strings. Close parentheses. So we have to do a few things to change this. We replace print with file.write. I put the 10 divided by I inside of a string function because we're coercing it all to be a string at the end. And then I'm using the plus operation with the /n so that we're sticking a /n onto the end of that whole line. So that gets read into, written as a file line as just one line. And the /n, it's like tab delimitation or comma separation. It's how that file is getting structured and will be read appropriately as a text file. We need these /n so that the line breaking occurs. And we have to do it for each of these print statements. So I'll type file.write for this first exception. This is already a string, ampersand I, and then we'll just add on at the end, plus parentheses, /n, and then again for the last case, delete print and replace with file.write inside these parentheses, plus sign, quotes, /n, close quote, close parentheses. And then finally, when you reach the end of the code and you're no longer going to write anything to the file, we have to tell Python to close the file. Otherwise, it will continue trying to write things to that file. It's odd and a little clunky, especially if you're coming from R with some file write experience. But it's just how these functions work for Python. So let's try this. Everything we need here, we have the file open, the file name, the fact that we're writing. We have this chunk of code that's going to do this loop and some calculations and write different lines of code. And then finally, we close the file. We'll press Control or Return. Code ran. Nothing was printed to the console, as was the point. The point was to just write all of this to a file. So now I'm going to go to my Day 3 materials folder on my desktop, open it up, look down and find, great, I have a .txt file called filename.txt. I can open it by double clicking. It opens as a text file and it has all of that content that I tried to write that we had earlier printed in the console. It's now been printed in here. Excuse me. Any questions from folks or problems with getting that to execute and run, getting that written file to show up? Add the last which part, the file.close. It may try to keep writing files. It may also not give you a file you can open. So I'll try making another file with a new name. We'll call it file name 02, but I won't include the file.close function. And so I'll run this code, Control Return. Everything here looks the same in the console, so let's just go back to this folder. Here I have a file called filename.02.txt. Nothing shows up in the icon thumbnail. I try to open this. It's empty. There's no metadata for the file. The computer's basically Python sitting there with the file open and still waiting to do more things to the file. And so now I can't do anything with the file. So we need file.close to to close the file is not a helpful way to describe it, but it's as I mentioned, it's just how Python likes to do this. So there now it's a file that really exists, and I can open it, can look at it. Yeah. Other questions from folks? Yeah, Python will handle CSV files. There's different functions that are structured for working with CSVs specifically. Okay. Yeah. Okay. Let's go to reading a file then. So to read a file, we use the same open function. Now we're going to change the W parameter to an R. So now I'll type file equals open, parentheses, quotes, file exists. It's called filename.txt, close quotes, comma, now in quotes I use R, short for read. We're going to read the file. And I hit control return. Not in the variable explorer, that's fine. Right, okay. We can now inspect this file using the read methods associated with the file object. For example, file.readLine will print one line at a time, and it'll do so sequentially. File.read will print all of the remaining unread lines. So let's try these. We'll do print file.read, hit control return, and now printed to the console are all of the lines in that file. We try it again, control return, nothing happens. You only get to do this print of the file contents once, then you have to reopen the file. It's clunky, that's what we have to work with. So if I want to go line by line, I need to have another instance of file equals open, filename.txt, quotes, comma, R, and then now I'm going to do print file.read line, open, close parentheses, close everything in the end. And I'll run this, control return, and now I just printed a single line from that file, the 10.0. And in this instance, since if I keep running this block of code, since I begin with using this open function, I still only ever print the first line of the file. If I go to the console instead and type print file.read line, open, close parentheses again, and I run it there, now we're going through line by line through that file and then advancing to the next line. These read and read line functions are slightly helpful. If you want to actually interact with the file, we have to do one last extra step to make it a little more of an approach for interaction. This is more for just sort of scanning file contents in a text file. So let's suppose we want to interact with the contents of a file to do something with them, and then we can assign them to a list in Python using a for loop. So here we'll run another instance of file equals open, filename.txt, read for the file. I'm going to define an empty list. We'll call file list. So equal to square brackets with nothing inside. We make an empty list. And now I'll type for I in file. So now I is going to take on each of the row entries in file, each of the lines in file. Colon return. I'll type file list dot append I. And then finally, we'll type file.close to close this file out now that we're done working with it. So press Control Return to execute this loop. I'm gonna add another cell here. Oops. There we go. So we can examine what file list looks like. Press Control Return. And now we can see here are the list of all those entries from the file. They're stored as a list. Within each list, these are strings. They have that /n character because that's part of the text file formatting to insert line breaks in each of the lines. Okay. Suppose you didn't want all of these to be forced to be strings, then you could try as you like. You could have a float coercion function here instead. If we try and run this block of code. Oh, no, float the whole thing. Sorry. No. Float just the object I. There we go. Okay, try that again. Except the problem is we have these actual strings where ABC can't be converted to a number. So we have now a different kind of error instance occurring. Okay. Yeah, and then leave it as a string in that instance, exactly. Okay. And then finally, we'll come to appending to an existing file. So suppose you don't want to overwrite an existing file, you only want to add new contents to it. This works just like the write function, only we use the letter A instead of the letter W. So I'll type file, open, parentheses, file name.txt, now in quotes the letter A for appending new content to a file. And I'll type file.write, and then write in quotes exactly what I want to write. I'll just type the phrase one more line with another /n at the end for the line breaks, there. And then file.close parentheses. Press Control Return. Code is executed, nothing's printed to the console. I can open up, I need to open up a new instance of the file from my day 3 materials folder. So here's file name.txt. I open this file, I see I have everything, all the content from before, as well as the phrase one more line added to the very end. Okay. Any questions on input-output writing with files? Okay. It is true these functions are slightly clunky. My feeling with Python is that's meant to give you a little bit more kind of hands-on control over the contents and how the contents are parsed. There are other functions though that are meant to help you with opening and editing different file types. So this can be specific to the data you're working with, or maybe if you have CSV files, you have functions for opening CSVs into Python. With the other courses we have, those should investigate and use some of those scenarios, those different types of files. Oh yeah, absolutely, of course, 100%. Okay. All right. Now we're going to move on and talk about Jupyter a little bit, and then we'll be done and move on to the last project for the workshop. So Jupyter. Jupyter is a web-based integrated development environment. It kind of takes a lot of the ideas you have from Spider, but makes a web page out of them instead. You don't have to have access to the internet to use it, even though it's going to show up in a browser. But you can it has a web address, and so you can share copies of your Jupyter pages with collaborators, for example. So to access Jupyter, you can do this one of two ways. You can either open the command line or terminal, and you can type Jupyter Notebook with a space between the two words and hit return. That ought to work. Although for some reason, depending on your installations, that might not work. This happened last time. So I'm just not going to actually do that approach. And so just say it's an option. Instead, we can also go to Anaconda, the navigator here, and we can just click on the launch button under the Jupyter tab. And it should have the same effect of opening Jupyter for us. It pops to the terminal because it's what it's running through to do this. And here, now, good. We have, what Jupyter will do is it'll access your default browser. For me, that's Chrome, and then opens a new tab. And this is what a Jupyter navigation window looks like. It's got its own fancy little icon. It's got a header that says Jupyter. And then if you look carefully at what all these folder names are, it's showing you the contents of your main user directory on your computer, on a browser, which is fine. This is how it formats your interaction with your computer for these purposes. I provided us with some example Python notebook to work with. So I'm going to navigate to my desktop so I can get to the Day 3 materials folder, the content we downloaded at the beginning of today. And then here I'm going to click on Day 3 Jupyter example. I gave you data file reader? That's funny. And it takes a moment to load if there's lots of content like there is in this page. So I just found a tutorial from the internet that was formatted all on Jupyter and then just borrowed their page and shared that with all of you. This group, they have a bunch of Jupyter-based tutorials for data mining, statistical modeling, learning from data, machine learning. And this section is their intro to Python programming, which is perfectly fitting for our workshop. And also helps serve nicely to demonstrate Python, Jupyter. So this is a very nicely built Jupyter page. Let's make a new one real quick so you can see what it looks like. So I'll go back to this previous tab that just showed all of the contents in our folder. I'll go over to this button that says new, and I'll click on new. So what would I like to make? New notebook or other things? I'm going to make a new notebook, Python 3 notebook. Click on that, and here I have, here is a blank, empty Jupyter notebook. And it starts with number 1, a cell. And in the cell, this is like a block of code, like the blocks of codes we've been using in Spider. I can do anything I want in here. I can type 2 + 2 and hit Control Return, and it runs it. Says here's in, and it gives me some output. It didn't give me a new cell. Oh, there, Shift Return gives me, it executes that cell and then gives me a new cell to run. And in here I can type anything I want. String equals, in quotes, string, hit Shift Return. It defined string. It doesn't have a variable explorer, so it won't show you a list of all the variables you've defined or the files you've read. You kind of have to keep that in mind or scroll back to see what you've done. But string is there. I could say print string, Control Return, and now it prints as the output string. And so these notebooks are basically lots of small compartmentalized blocks of code that you can use. But the nice thing is you can also change this. So there's this drop-down menu here. I click on it. I can choose between code, markdown, MVC convert, and heading. Usually we only use code and markdown. The idea with markdown is if you want to make text only to type, say, here is some text like a comment, I hit Shift Return. Now that is saved like a block of text as opposed to a cell. So it's this nice way of kind of doing half website building-ish work and half code compiler at the same time. And if you spend enough time with it, you can make really nice things like this example on the other tab that we opened first. So you'll see here is this big block of markdown code. The drop-down menu automatically says it's markdown, and that's where they put their title and names and the heading for this exercise. Here are some more cells of markdown code. Python program files, they just list some file names that they're working with. Here they describe notebooks, modules, there's a lot of markdown here. And then finally here, they have their first line of code, import math. They open their tutorials talking about how to import the math module. And you hit shift return, and you can work your way through this worksheet, for lack of a better phrase. So it's very nice. If you work with people who use Python and you want to kind of put together this nice pseudo website / interactive coding experience to maybe present to folks some data analysis, you can use Jupyter to do exactly that. And then you can just send them the Jupyter file. You don't have to send them a copy of Python. And so maybe if you send them the Jupyter file and like a zip folder of data, then they have like a bundle to reproduce some analyses instead of giving someone just a raw .py file that they have to work with. Yeah, exactly. So to that point, I primarily only use Jupyter for my own programming work because I just like that aspect of how it kind of organizes everything for me. So I basically have like a whole set of functions, and all those functions sit in 1 or 2 different cells depending on how I organize them. And then I just run those cells. Now those functions are executed and they exist, and then I can use those functions in that same sheet elsewhere. Oh, yeah. Yeah, like so yeah, the variable thing is frustrating. I just have to scroll up and remind myself what letters represent variables here, which ones don't. It's a shortcoming, but it's I don't think it's too bad for what you get out of it.
Where are errors?
Great. How about some errors? Do they have loops in here? Yeah, it comes out in the same way. Yeah, exactly. I just want to find. Oh, they did some. Yeah, here you go. We'll make a indentation error. Excellent. So right down where the output would show up, they just give you the error instead. Let's see. Yeah, and plots and graphs and stuff, those will be saved down into this bottom page as well, which can be nice. The other thing is you can also save this as a flat website. So you don't have to send someone the version that doesn't have the uncompiled code. You can send them a version that has everything was compiled, and then it's basically like a screenshot, but they can scroll through the whole thing. And so you can have kind of 1 or 2 versions, one where it's interactive with the code or just one where it's flat, but they can see all the end states that you produced with everything. Download as, no, oh, yes, PDF via LaTeX, kind of. Let's see what happens for fun. Go faster. 5, 4, perfect. There it is. Yep, you can totally make it out as a PDF. Cool. Okie dokes. All right, so that's Jupyter. That's all I have to say about Jupyter. The activity for today is using Jupyter instead of using Spider, just to get you a little more hands-on experience with it. Aside from the front-end differences, it's really just like you're working with Spider. You'll point to the directories and where you're reading and writing files, and then writing and executing code works all the same. So what is that activity? Here it is. The final activity that we've learned today to read into Jupyter, the second file of data I've provided you with. That second file of data is called day3data.txt. There it is. You will need to add some code to remove these /n terms from the end of each line and to coerce everything to a float so you can do some math with it. Go ahead and open the file and take a look at it so you can get an idea of what kinds of errors might be generated when you do that. And write some try and accept statements to handle those potential errors. Or don't look at it and then just figure it out as you start reading through it. That's fine. Finally, once you're able to coerce everything in there to a number as necessary and handle the errors, then use the variance nums function from your stats module to calculate the variance in the list of numbers that you just read into Jupyter. And then append the line of text to the end of the file, the phrase, the variance is, and then that number, what the variance is. Having rounded to 4 decimal places, attach that to the end of the file. It's a tall order. I'm going to give you 20 minutes to do it. Don't worry if you don't get through there. The point is to practice lots of these different aspects. But I'm going to cut it short so we can finish those surveys in class before we leave. As with all of our exercises, please pair off with a neighbor nearby and practice the 1 computer, 2 people approach to working on this. Okay, go team go.
It's really early just because I got some lab
Oh,
work.
you have to get out, sure. There it is. Yeah, thank you. The same thing, okay. Perfect. Here's your copy. Thank you. Yeah, that's fine. Thank you for.
Oh, you just press me up. And you chose what kind of format.
Yeah.
Yeah, I didn't read some questions there.
So is it, it's on the desktop, is where you are? So that's where this is looking. Oh, okay. Cool. 4. You get to type the file in here. You could type the whole path as well. Yeah.
I know, but yeah.
You definitely because of the next week.
Yeah, I just like that.
Cool.
That's the graphics.
Oh, yeah. Yeah. All right. See you around.
Mm-hmm. Sure.
And then additionally, you're gonna read, you're gonna print one of the lines. Print line list.
No, just I make sure that I go to the right one. It did.
Yeah.
Yeah.
There's the file's not closed, and then when you print the last one, the file is, and you print this line list. But line list, the idea is that you have everything in it.
I hope, yeah.
Well, if you go here and look at line list. Line list only has one thing in it. Yeah, I think this printing negates your ability to read through the rest of it. We did those separately.
Yeah, I don't really understand why these read and read line functions do this. I think try removing that. There you go. Now you have the whole thing.
Interesting. Okay. Good to know that.
Yeah. It's something about how they work is for if you're scanning through a large file and just going line by line. The function is just what it's doing. But you want to take each line and save it to a list item so you can use it next.
Okay. So anyway, back to the sign.
Yeah.
Maybe you can clarify both of us.
Sure.
Like, do you want us to read the file you already have
Mm-hmm.
and put those individual numbers into the list?
Yep.
And then
Some point.
because I think when you switch like 5.0 slash and you kind of just force it into the file. Probably one thing. Yeah, we have to get rid of the and. And then we need to import the module, status module, and then use the function there to do variance and output the variance.
Yep.
That's the goal.
Yep. Okay. Cool. Yep.
Next.
Go step one.
Okay. So I'm going to pop it back in my head. I want to use the file. Yeah. So we get the first file.
Okay. And close. Do you run this? Okay. So then let's look for day3 data list up here. Great. There it is. Okay. And now let's can you type down here maybe in your console day3 underscore data list so you just see what prints out in the console. Great. There it is. Green. So this is what happens when you press the green run button, is that it's running the whole script. So it says run file, and then if you look at this, there's a directory for this file, and then it gets to the last part, which is day3_data_analyze.py, which is the name of this tab. So what's happening here is this is a function that runs your entire script start to finish. What are you trying to do? So then you're just running, you do that, you're also running the whole file. But that's because you don't have any cells.
Yeah, but he already provided this in this folder. Day 3 data. It's called day 3 data. Yeah, you can find that.
So this is the folder trying to know the slash tag.
So he already created this.
I'm gonna so when you do this on Jupyter,
What did the Jupyter right there?
print file read. Okay.
We need to try it.
And then what's here?
Remove
This file.
remove
The
this.
slash. Okay. So right. Oh sure, try it.
This is correct, but this is the file.
I've never used this function, but no, but I'm happy to see if it works. Math object. Is this exactly how they use it in that help page? They do it inside of the with open function. So I would try copying and pasting exactly what they have, and then changing the parts out with your files, and then see if it works. Oh, you're missing the W. There we go.
So instead of this, I'm going to put the day 3 down.
Yep.
Can we just set what this has? Yeah, I actually don't know how to set the tab. Right, if you look at this, how to set the tab using Jupyter. I have no experience with Jupyter stuff.
Not sure the help page. Is that helpful?
Yeah.
So can you go back to that page quick? I'll show you the hint. One person thought this was helpful. That's what that one means with the green check. And so the green check means this was accepted as the main solution to the question posed. And then one upvote tells you one person like, so there's green check right here. One person.
It tells me
Yeah.
this.
So when you're looking around for answers to your problems, you're often going to find multiple answers. So you have to pick the best one. What's the one with the most arguments? And the one that sounds looks that word is not useful explanatory.
So this is
Oh,
here.
I don't need to.
I see this in the string. It's like that's okay. Yeah.
Sure, but you try another one.
Oh, yeah.
Yeah.
Yeah. Right. That's what we're trying to figure out how to set like the folder which will recognize and read the file.
You could also
Recognize it.
try some of the other things we've done in class instead.
You can add it
So
to
earlier today,
that.
when we were talking about reading these files, we showed how you can save every element from the file in a list, and then you can operate on that list separately. So maybe try that from it'd be in the reading section of the previous.
We haven't reached like that's that. Yeah, that is.
Yeah, the reading file part where I wrote a for loop.
Yeah.
And here, this for I in file, files and I.
Just then bring each of the lines as one
Entry in the list.
entry.
Yep. more thing. To the beginning of this, so go ahead above the F and 4 and hit return. Yeah, because we need one more thing in here. And then above, type file list.
No, I think you just need to
Just file list equals square brackets.
actually okay.
Square brackets.
Yeah, obviously, yes.
Perfect. Because you need to initialize or you need to make an empty list.
Oh, so I should do that in the computer.
Yeah, well, you just need to do that before this. Oh, and then it should work.
Oh,
Huh?
yes, I actually have a quick question to ask.
I can't even get it to read in here.
Oh. Let's see. Here's your account. It's in your downloads folder, day3data.txt. You have a W inside of that file function.
A W?
Mm-hmm. At the very end.
Oh, here's the most recent one.
Oh, sorry. Okay. I got mixed up.
Yeah, I did that first.
Do that. Read, and then nothing happens.
Yeah, nothing happens underneath. I tried trying to find
And we're 100% certain that file is there.
Yes. Yeah. Is it day 3 student? No, it's just data, right?
Mm-hmm. What if you remove the print statement?
Or just do file.read?
Yeah. Empty quotes. Try running this line again with the file was open.
Oh, here.
Yeah.
Wait, can I just run this again from here?
Which? Yeah.
This here.
Yep. Yeah. Actually, you can just go back to the previous cells and run those
And those
independently.
will get.
Yep.
Okay.
Yep.
Let's check return.
Yep.
Yeah.
You can just go back to that one if you want to.
Doing the same thing.
So if next thing I'll do is say, okay, everything you're doing looks like it should be working. Maybe for some reason this file is empty.
Right.
Can we go open that file? Oh,
Where is everything?
it's gone.
Did I delete it somehow when I did this?
Yes, maybe.
That's possible.
Um,
Because that's right.
Yep, it was a write, and then it doesn't look like there was a file close that came.
Oh, I never did close it.
Or
I did that earlier when we were still.
yeah,
doing that.
yeah. So or it's what happens instead of because of write instead of append, you just overwrote the file.
Yeah. Do a nice blank file.
Cool.
Great.
Yeah.
So I had to re-download that
Yep.
data file. Okay. Oh, good. That's too bad.
Yeah, that's a good lesson, right?
Yeah.
Sometimes you should be trusting of what the code is saying that's coming out. It's like it's empty. It's like maybe it's really empty.
This is when you don't follow Google Maps and it's telling you, it's taking you to the right place.
Oh yeah, exactly. Yeah, thank you.
Will this this portion be up?
Yep.
Or you're gonna- Okay.
Absolutely.
I'm gonna head out. And what was your email? Did I forward you the PBM
Oh,
stuff?
right. Thank you. A Brummer.
Let me just write it down. A amendment or?
No, you see like you.
Got it. Thanks.
Awesome. Thank you.
You're welcome.
Great.
I think just open the tactical data. Yeah, the same thing what we have. Like, tactical data.
In file, where is can you go back up there? So we have to run that. Okay. That one.
The one that
Hang on. Don't do this one.
Don't do that.
Yeah, so just do this one, and then scroll down, and now run this one. Excellent. Now try your print finalist. Perfect. Okay.
Now we have to remove this.
Remove the ends.
Thank you, sir.
You're welcome.
That was very nice.
Sure. Cool. Wait, sorry. What were you saying? Oh, yeah, this is what's funny. When you do this, print the list, what happens? Well, it's sorry. Okay. The list. That's what shows up here. And so if you come in here and just type like day 3 data list. There they are. Yeah, I think it's not showing up there as part of the parsing data for that object in the variable explorer. But you can see in the console output it is showing you the sign is there. Start. You have reading the files. Yeah, you've got like a list object of the contents. Yes. Yes, that's for two. That's for perfect. Okay, so great. Now we're removing slash ends. Yeah, I know how to remove just slash ends. So here's cool. Right idea. We're using the pop. But here's the problem: is that the pop function removes elements from the list, and so the slash ends, they're not their own elements in the list. It's that every element in the list has a slash n at the end of it. So you need to get for each element in the list, then you remove the slash n, as opposed to popping the whole slash n from the list. You guys see what I mean?
Yeah, I'm trying to do that. Because currently, once I don't float right now, each thing in the list has a string of this option. So I thought maybe I tested to see you can't just subtract the part of this. That's great.
You guys do that, that'd be cool.
Yeah. You can add it. I don't know why I can't subtract.
Because I remove the end of this.
Are there other ways to? Are there other string methods we can look for? Good. And then just see if anything sounds like.
Or you can remove the comma. And it's going to replace the ends with the end with space.
Oh, ends with.
What's that?
It just tells you what it ends with. Doesn't get rid of it.
I'll handle the errors. Yeah. I haven't get the tort. I just remove the ends from that. So I want to force
Split strip. I don't know if orange strip and L strip.
Those could work.
It sounds common. Oh,
R
this is
strips, and L strips, and strips, yeah. So you could explore some of those. If there's not anything that jumps out at you, then the other scenarios you could try some indexing.
Great, you can index the string.
Okay. Let's see, do that. String dot string. How's it going?
Yeah, I think it's going good. But we are having a little bit. Oh, that does it. Okay, cool. So the strip function, you can take away a specific part. Because the string was originally A, B, C, D, E, F. So you can just remove the G, E, F. So if you want to do a for loop that runs runs through every single one and then says strip that one of okay. Easier said than done.
Oh no. It's so close. Where's the line where you had it?
No, try.
Did you remove the head? What did you remove? You know what I mean?
No, the problem is that I can't open the file.
It's really easy. If we open the file to read it, we have to post the reopen. We have to post it again.
You want to leave it? I think so. I can't hurt you. Oh. So it sounds like it was working the whole time. It's just that because you didn't have it closed, yeah, it just kept doing that over and over and over.
Well, just check what the variance numbers. We just have the variance numbers. We did like variance numbers and then we put file list.
You just run the function inside of right? Yeah, I mean the other option would be you do it outside of the observer in there.
Well, why would you try to crank the variance?
We tried to fix it the first time. It was the
Yeah. After we added the, after we rounded it.
$24 doesn't return.
What is the variance number? What's that?
So it should
Yeah.
Unless there's a square. And there's never stand between 0 and 100. Yeah, so if they're normally distributed around 50, and goes more than 100, then that and then if it's a square variance, that might not be there. There's standard deviation and variance. And I think variance is square. It's not. It's just a county square.
Cool. These standard deviations like you have like first like one either side of 68.
Right.
34, maybe 34 squared.
Oh yeah. Yeah. We're starting around 50, 60% out.
Yeah, so it's like it wasn't all the way through.
Cool. I like these arguments.
Yeah.
That's good. Yeah.
Let's say we did add like a bunch of these. Should I use like cost and should use for
Yeah. Or you can just open the file and leave that lines and then start over and see if it works this month.
Secret programming tip.
don't always have to use programming to open and close files. You still have mice. Yeah. Invalid syntax. Sure. Anything else the surveys? Then I'll come right back. Okay, folks, great work. As I mentioned, we're going to switch gears and do these closing surveys for the course. Please, we'll do this and then we'll be done for the day. So when you're finished, please feel free to leave. That'll be the end of the workshop. As Ella mentioned, you'll receive an email that has a link for the online surveys as a surveying the course itself. These surveys are in here are part of the sort of methods research I mentioned from day one. End of today, I'll post both my version of the tutorials with all the information filled in, as well as code for how to do this last task. It'll be posted as a Jupyter notebook, so it'll be a little different finding where it is. And of course, I'm happy to answer any questions folks have afterward. Right, and you if you what if you put a comment on that exception? Oh, I know, there's no try. I think that's all. To do the exception, you first have to have the try part. And then that should help. No, the accept and try, they're both aligned together. But what's the code that you want to attempt to execute that might generate the errors? No. Here, you have this accept value error. In other words, we float. What's sure? No, that's fine. What part of this code generates that error? Is it this one? Okay, so that needs to go after the try. Sure. Yeah, and then it'll do the whole part. And then you'll need to tab the if over. As well as the part. Yeah. No, that's fine. Keep that adjusted with the try. New. Oh, wait, you want to open data file.
That's the Jupyter file. It's a TX, it's a .txt file. The name is here, day3data.txt. Yeah, that's okay. If you still want to fill it out. I think you can still have that. Kind of. Mm-hmm.
I just wanted to say thank you for the way you talk. I found it was very understandable.
Great. I'm glad to hear that. Yeah.
We've changed to the
Yes.
like this is the list two that doesn't have the
Try it. Oh wait. Yeah. So you want to, that's great. So you're not going to overwrite the list. You're going to change the things in the list.
Yes.
And then you want to save them somewhere else.
Yes.
New float list.
Yes.
Perfect. So you have float list equals rank list. Excellent. So now float list exists. So you can use the float list append method to append something into it. Parentheses. Now, what do you want to append to float list?
Is the float of this
Over.
the float I.
Yep. Try.
Errors.
Failure.
Because we have
Errors. We have errors.
now we have to do the
Yeah, exclude the errors. Good.
but the thing is that the example is giving you this. Otherwise, I would do it from
Where? Oh yeah, your eyes are red ones. Yeah, that's tough. Looks good. Yeah. That's looking good. So now the stats modules work. Thank you. The very last part. That function is inside of the stats module. So that it's called stats. Thank you. Stats underscore module I. And inside there it has a whole bunch of functions for various statistical measures.
Questions?
Yes.
How to read this file from Jupyter? I don't think to figure out. I tried to write something like that, it didn't work. Look up some
Did you try to
people.
add the space between the open and parentheses?
Oh, space.
Yep.
Okay.
Mm-hmm. It may.
And the other question, how can I, do this full thing?
So one thing I'd suggest is try using multiple cells instead of doing it all at once, because then you can attack it
Right.
chunk at a time.
But there should be a way you can do it.
Yeah.
Yeah, something like that. I don't know how it works. I need to look it up. Something like that.
Wait.
How do you expect?
Oh,
Invalidate.
Yeah. Okay. Number 10. Yeah. Thank you. Good.
I probably should
Good.
look it up.
I
forgot to look it up.
There is no way.
There's no way.
You can't not Python just on Jupyter. You can't block document cells. Yeah, it's a great. You go online and ask about it, and people are furious that this doesn't exist. I know. It is super frustrating to go through and put a comment on every line manually.
Okay,
Same with indenting and tabs. There's no. That's why I didn't know that about Spider when someone mentioned it. Just,
Thank you. Yeah, enjoy so much. Yeah, enjoy Thursday.
Yeah, like I only use Jupyter, and I just learned this is the fact for Jupyter I can't do it. But then when someone said Spider you can block that down, then yeah. Sure. Whatever you feel best describes your current
programming expertise. Thank you. You're welcome. I'm in your chair. Sure. Mm-hmm. Chosen function or method object not descriptable. It's going here. Dot append. Wait here. That's what are we doing? I'm reading type error. It says something. Let's try to it says something's not subscriptable. That's another word for indexing. It means we're trying to index something that can't be indexed. And here's point to the line. That's what this arrow is. Look in here. So something about this line is wrong. And the subscriptable means something's being indexed that shouldn't be in this line.
Do I need to define
No, it looks like you did that previously. So I'm guessing that's going to be fine. I'm focusing strictly on what's in this line. How we typed it. What are we trying to do?
And then append it to the list and then new list.
Okay, sounds great. Now let's look at what we've typed. We have float list, which exists. You made it here. Float list.append should work. You're going to append something to float list. What have we done next? Are these square brackets or these parentheses? Yeah.
When you first open Jupyter, the basic stuff. You draft the file over there.
Now let's try.
Yeah, you just it should show up there.
We plug in.
Yeah.
Progress.
Every time
Fixed one problem. It's moved on to the because it's gone to a new line.
That's
So now we're here.
Yeah, I read something online. It mentioned.
Unsupported offer
Okay.
type store.
Yeah, when you first open it, it gives you like a list of files directly, and then I just put the file right there. I'm sure there's a more sophisticated way, but that's as far as I know.
Thank you. Thank you. No problem. See you next week too.
Yeah, I think so. Is it the same day? So one day or something?
We used this with
Probably not.
Oh, okay.
Okay.
Okay. Yeah, I'll definitely take it now. Right. Yeah. See you then.
See you then.
in handling of the above exception, another exception occurred. Not writable. Close. Oh, we don't have a file to open, do we? Where we start writing? This is for reading. Here we have R for file open. I scroll back here. Oh, R. What's happening?
Do I need to close it somewhere?
I think we need to open it somewhere. I'm having a hard time getting back. There it is. Yeah, I think what's happening is it won't rank because we haven't opened a file to write to.
Open.
Yeah.
Like this.
Like that.
Oh yeah, I still have to
Sure.
figure out how to just read the file instead of like dragging the file into the file folder.
Okay. Comma close and then print lineless list.
I even tried double that.
Why do we have these two lines?
Oh, we don't have to. It's just append.
No, I mean first you set up line list as an empty list, and then
Oh, they
line
do the
list.
same shit.
Oh, okay, cool.
Yeah.
All right, great. We got rid of one. All right. Line set append. What's the strip do on I?
That we don't do it. Fine, I guess. Doesn't matter.
Okay.
Because I need to make sure I can read it.
Okay.
So
Cool.
I can
And then
move
file dot close. Where do you define file?
That's the point. But
I know.
yeah,
This
Jupyter
is programming.
Give you the Does it give you the words, the singular word you get wrong?
No, yeah, the error handling, like when it works, it's really great. But then it's also like it doesn't catch what you would think are like the obvious things that are happening. Oh yeah.
Yeah, it makes sense. Yeah.
Perfect. I am glad to hear that.
And actually, I looked it up. Like people actually put 2 different errors. 1%.
Oh, cool. They did.
Yeah, one overflow.
Yeah.
Stack.
Stack overflow, I think.
Okay. So to somehow access each of those individual entries, we gotta remove /n from it. So it's something that will do to all of them. Like for every thing in that list, it will do the same thing to them. So maybe, maybe use a for loop. Yeah,
Actually, you can just like,
And then it looks like they all have those /n.
that's probably easier to find out. Stupid error, I typed it wrong.
Oh, yeah. Made some way.
So do you finish the code?
I have not, but
To select everything
Okay.
but the /n.
Yeah.
So you need this.
Did you get to the point where you calculated the variance?
I cannot, but like you have to import
Yeah.
the module.
Yeah, it did, and it works.
Right,
But the variance you calculated
each of these is a
way
string.
too high.
I mean, so
They're 31. So indices, the numbers are all into
grab the parts you want.
they're all less than 100. That's way too high variance. So it's not a problem in any of the code. It's a problem in the variance function itself.
Was it a variance?
831
It's the same. Other folks got.
seems like a really high variance.
It's here we're trying to work this out. Right? So variance is standard deviation squared.
Yeah.
The numbers range from 1 to 100, and they're roughly. Let's just suppose they're normally distributed about 50. So then one standard deviation is going to probably run roughly from like 30 to 60. So it's a value of 30, and then if you square that, it gets it pretty large.
Yeah, totally. Usually in practice, we use the standard deviation out of it.
Yeah.
Square, if that makes sense. That the standard deviation should be about square. Okay.
Cool.
Yeah, it's just
And then in the event that it's uniformly distributed, then it's going to be huge.
Yeah.
Variance.
Yeah.
Okay. So we should be good.
The function is good.
Because I don't know. I didn't
Especially in the Python.
just someone else wrote it. And you're all set with this?
Yeah, that's great.
I got an error. I just opened my phone.
Yeah.
After I had a final post, and then I got a random. I then I have to say
Right. Because here you have value error. We have an exception for value error.
yeah, but after that,
Okay, no, you just executed the empty cell. Or if you go back, put the cursor here, and then press run. Because it's okay. So let's look carefully. What line is it pointing at? Fine. Which is there. Where is your try?
Here.
After that line.
So it should be before. Okay.
Yeah, the code that you want to be attempted to be executed has to come after the try, not before it. Mm-hmm. Yeah.
I don't know.
How to use it?
From attention. Yeah, or you can import all of them or just the one. Either should be fine. Oh, but this is different. So this is, the idea there is you're printing the statement. So we better just have all of that inside the print function. Right. And then square brackets here, that's just meant to be there, put the number that comes out from the variance function. You do. So if variance nums is a function, if that's the name of a function, then try typing that as if you're going to use it like a function, like the max function or the min function. Now you have variance nums, and then inside goes that list of numbers you made from your file. Okay. Because you have here, float list out of pin float I. Oh, sorry. When I said after try, what I mean is this has to come in this line after the try command.
Oh, sorry.
Yeah, right there. Uh-huh.
Let me close that. Oh, yeah.